So, hey guys, it's great to be here. I'm a big fan of Varnish. One comment up front, the next 30 minutes are not specifically about Varnish. I'm going to talk about something that's, I think is related. So I work with, or at Google, I work with the Make the Web Fast team, the creatively titled Make the Web Fast team. And we have a number of projects within this umbrella. One of them is Mod PageSpeed, which is an open source module that is actually an Apache module, as you can probably tell by the name, to accelerate your site. And this is something that is, so we actually saw a screenshot earlier, or I guess it was as a real demo of breakdown of where the time is spent on a typical website in terms of the total latency that the user sees. You saw the connection or the queuing latency, you saw the server response, and then you saw that big giant fat graph of like, this is the stuff that happens in the client. And specifically, Mod PageSpeed is trying to address that. It tries to bring some automation tools into that land. And while we don't have a solution for Varnish today, I think that's something that we would like to see, would like to engage the community. And for that, we actually need some additional capabilities within Varnish. So I figured, it'd be interesting to just talk about what it is that we're trying to do, because it may be even applicable to the sites that you run today, and maybe something that Varnish could support as well. So the preamble to this, or all of this, is that performance in general is actually a very complicated topic, right? There's my office mate, Steve Satters, wrote a couple of books about it, and frankly, it is a full-time job to keep up with the ever-changing landscape of all the things that you need to do. The browsers are getting smarter, the pages are getting bigger. An average page on the internet today is about 1 megabyte in size. It's composed of 80 requests, and those 80 requests connect to 30 different hosts, right? And we expect those pages to load in hundreds of milliseconds. If that's not asking for a miracle, I don't know what is. So what do we need to do to all of this? And the other maybe quick aside is that doing all this performance work, while it's important, it also creates additional costs for your team, for anybody. So for example, things like spriting images. Like, why do we need to sprite images, right? It's a giant hack due to the limitations of the current HTTP protocol. We're basically saying small requests, we can't, or we don't want to make many small requests because that will consume many connections. So let's just pull them all together in one image and then use this CSS hack to position it on the page. Not very interesting. So that's something that we need to address. And all of this stuff just creates additional burn on the team. So our insight, or I guess our premise for something like Mod PageSpeed is a lot of these things can be automated, right? We can make machines that, or we can make code that will do this automatically on the fly for us, such that you don't have to do it yourself manually. And that's effectively what Mod PageSpeed is. The entire insight is that it's a performance JIT. It's something that runs in your web server. So if you guys are using something like Rails or Django or others, there's actually a lot of work right now in those frameworks to build additional pipelines or build steps that will, for example, take all of your JavaScript and assemble it before you push it down to your production servers. So it's done almost as a build step. With this, we're saying, let's push that even further up into your web server. And there's a number of things that this enables. So basically, it optimizes your content on the fly. And the core behind Mod PageSpeed is actually another open source project that we have called PageSpeed Optimization Libraries. And this is a C++ core that is basically responsible for rewriting content on the fly. So I'll have a diagram later. But what this means is that the Mod PageSpeed is basically a wrapper. It's an Apache wrapper on top of the C++ library. So that's the part, if we wanted to integrate with Varnish, we would take the PageSpeed open source libraries and kind of build the necessary API shims to make it all come together. So a little bit about PageSpeed. We're actually, next week, we're going to ship our 1.0. Google is famous for the perpetual beta. This thing has been in beta for 2 years. We have, on the next slide, we have over 100,000 users using this today. There's a lot of rewriters, basically optimization filters that you can enable, toggle on and off, all that kind of stuff. We support all of the popular Apache versions, etc. So I think I touched on this already, but the basic premise is we want to eliminate things that you don't need to do. And this brings a number of benefits. So first of all, if you have a large or distributed organization, you can now, you don't need to build rules around how do we roll up our JavaScript. that the web server is responsible for that. Another very popular application is hosting providers, where the problem we see quite often is, if you're building your custom application and you have a dev team behind that, you're probably, well, you are already way ahead of most of the internet. Most of the content on the internet is generated by users who don't think about web performance, right? I have a blog, I take a photo, I upload it to my blog, and I resize it in HTML. So guess what? You're getting the 6 meg image that's going to be rescaled in your browser. And you're downloading the entire 6 megs. And you may be viewing it as a 100 by 100 pixel image. And that happens way more frequently than you think. So here's some numbers on the adoption. So 120,000 users. We have popular providers like DreamHost, GoDaddy. I know that GoDaddy is maybe not the crowd favorite, but they host a lot of sites. And you just have a toggle that says, make my site fast. And it's like the turbo button, which is nice. And Edgecast, a big CDN provider, they're actually using, they're not using mod pagespeed specifically, but they're using the pagespeed optimization libraries, and we actually work closely with them to kind of decouple our code and make sure that they have all the necessary APIs, such that they can push this rewriting capability, optimization capabilities, onto the edge of their cloud, and they can provide additional services for things like optimizing images and the rest. So here's an example. Let me see if I can play this. That didn't work out too well, did it? Oh. The Wi-Fi may be acting up a little bit. All right, we'll skip the video. So this is an example. If you guys have ever done kind of web performance work, you've looked at the network waterfall graph before, right? So it doesn't even matter what the specific resources are. You can just kind of look at the shape, and we can tell a story based on the shape. At least I can. I guess I've looked at enough of these. And it's the same site. On one site, you have mod pagespeed off, and on the other one, we're actually doing some optimization. So the first thing to notice is you have these blue bars, and these blue bars actually represent big images. These are images that are not optimized when they're delivered. So on the right, those bars are gone because we've found a better image format, and we've actually re-encoded the image on the fly or compressed it down, resized it, all of these things. So we're shipping fewer bytes. So that's the first thing to notice. The other thing is the actual waterfall is not as high, and that's because we're actually collapsing resources. So for example, if you have many CSS files, we will crunch them down and ship it as one file, and that's completely configurable. We can do similar things for JavaScript. We can inline assets as well. We can do a lot of extra work. So for example, if you have small images that you're embedding in your page, you can actually configure it to say any resource below 3 kilobytes, arbitrary, just inline it onto the page. And that can be a win or not, depending on how frequently you reuse that same asset. So this is kind of a high-level view of what you should expect out of it. So let's take a look at the world's simplest example. This is not even pseudocode, but I just wanted to show you an example of what a filter may look like. So this is very simple. We're saying, let's collapse white space. All right, so we are doing content or body modification as it's shipped through Apache. So we have this byte stream, and we're saying we're going to parse it, and we're going to collapse all the white space. Now, this is an actual filter, believe it or not, in mod pagespeed. And it's a little bit more complicated than it looks in reality. So we're not just running a gsub on all white space. It's actually more intelligent because white space actually matters in certain content of your page. So for example, inside of a pre-tag, that's your formatting, right? Inside of JavaScript, we don't want to be collapsing your white space because that could be significant. And in fact, this filter, we have two notions of filters. We have core filters, and we have filters that you need to enable by yourself. So the idea behind core filters is that you should be able to enable that, and just everything should work. Your site should never break. It should only get faster. This is not in core filters, as funny as it sounds. We've actually found sites which depend on the white space in the HTML markup, because the JavaScript that interacts with the content, it's crazy stuff. Anyway, but most people enable that anyway. Here's a more interesting example where you have a page and you have a lot of CSS assets living on the page. we parse the actual HTML. So we have an HTML parser built in as part of mod pagespeed. And we will actually rewrite that asset. This is configurable, but I'm showing you an example here. We have 4 files. We will generate a new file name, which will be yellow CSS plus blue CSS, etc. So this is literally just concatenating all the files. And then we have .pagespeed, and this is important. This is basically like an extension that we will look at later. CC stands for combined CSS. We then take the MD5 sum of all of the content, such that if you modify one of the files, we'll fingerprint it and we'll re-encode this file, and .css. So we will also extend, now that we have this resource, we will also extend its cache lifetime for up to a year. Because anytime you modify any one of the underlying files, we will just generate a new checksum, and that will get pushed out. So that actually works out really well for CDNs and upstream caches in our experience. So you can still hint to mod pagespeed as to how frequently we should poll you for the resource at the origin, but we will handle all of this kind of rewriting and making sure that your users see the latest content. So the net outcome of this, I guess, is that you will have one CSS file, which means 3 less requests, which is an example of why that waterfall would be shorter in the other example. So here's kind of a crazy looking diagram. I'll try to make some sense out of this. So this is specific to Apache, but the basic idea with Apache is that you have an HTTP request that comes in, and if you write any Apache module, you have a couple of different places where you can hook into. One is called input filters. So for example, you can modify your HTTP headers. That would be an example of an input filter. Then we have resource handlers. And a way to think about resource handler is just, for example, .php extension, right? So the handler looks at the extension, says, yeah, hey, that's for me. Given this request, I will generate the byte stream, right? So we actually have a pagespeed resource handler. And this is used for that optimized resource that we saw earlier, right? So when we look at this URL right here, we say, oh, yeah, OK, so this is a resource that was rewritten earlier. We know how to compose this resource. We will compose this byte stream for you. So that's an example of a resource handler that we install. But having said that, you can still use something like, let's say, mod Proxy and fetch resources from somewhere else. And then you can have pagespeed optimize those resources. And then finally, we have the output filter, which is just for the HTML assets. This is the part that does the rewriting of all of your content. And all of these pieces kind of come together and rewrite the content and optimize the assets. So perhaps if nothing else, there's 40 plus filters, but if nothing else, the image rewriting is one of the most important ways you can optimize your site. This is based on a lot of data that we've collected at Google through our crawling and everything else. And we just find that most of the time people are not using the most optimal image formats, or they're serving them not scaled properly. It sounds funny, but it's true. You're downloading massive, multi-megabyte files on your mobile phone, and you're seeing it as a giant, image, or sorry, a tiny image on your tiny screen on your mobile phone. And frankly, you probably don't even care. So one of the things that we will do, for example, in mod pagespeed is, as we're parsing the image tags, we will look at your image, or sorry, the height and width attributes that you set. We will then query or request the actual origin image, and then we'll compare those and say, hey, you're saying that this image should be 100 by 100, but your origin is giving us 1,000 by 1,000. So let's rescale that image and ship the 100 by 100. And that happens dynamically in the server. Another good example of the kinds of work that we can do is, for example, WebP, which is a new image format that Google open sourced, I guess, a year and a half or so ago. And it's supported by Chrome and Opera today. It gives us about 30% better compression on over JPEG, or on the type of images that we use for JPEGs, which is nice. It's a big win, especially for mobile phones. So if you're coming to a site with a mobile user agent, or sorry, with a Chrome or an Opera user agent, we can actually serve you a WebP image. But if you're requesting the same image through Firefox, we will serve you the JPEG. So this is a kind of example of rewriting that you can do when you push this logic to the edge. This is not something you could do easily even with custom build scripts or custom app logic within your app. So if nothing else, image rewriting alone would be worth a lot to speed up the web, even if we only implemented that in something like Varnish. I think that would be very, very cool. So as an example, right, we have an image. So the origin server has this image called puzzle.jpg. And when we look at the HTML that is serving this image, we say, well, we pulled out the width and height of the image, which is 256 by 192, and we're actually write it into the URL. We, once again, have our extension, and we have a fingerprint on this image. Plus, we're serving it as a WebP because it's a Chrome user agent. So this is the kind of thing that you would see when you enable mod pagespeed. And by the way, I didn't mention this at the beginning, but you can go to modpagespeed.com, and we have examples for each one of the filters. They're usually very simple HTML files that just are there to illustrate what we do. So that's a good place to start if you're curious. Coming back full circle, so how does this all work? I mentioned that we have pagespeed optimization libraries, which is this shared asset. We actually have a different service at Google that we're currently working on called pagespeed service. It's the hosted version of basically mod pagespeed, where you would CNAME your site to us, and we would do all of this rewriting through Google servers on the fly. So we're actually using the same code, and we're contributing all of the rewriters and all the logic back into the open source library. And we have guys like Edgecast and others who are also contributing back. So we would love to see more community engagement there and build more of these rules. But what the pagespeed optimization libraries give you is the rewriting filters, and they pull in a whole bunch of dependencies, fortunately or unfortunately, that are required to do all of this work. So it is a pretty hefty library in itself because we need to do a lot. We need to actually parse the CSS, we need to parse the HTML, all the image encoding stuff, etc. And then what optimization libraries expect is certain interfaces or APIs that needs to be provided by the server. So for example, just a cache layer, right? So in Apache, we have our own disk cache that we've implemented. Varnish has a pretty good one, I hear. HTTP fetch capabilities that, once again, Varnish has that built in, so we can hook into that. For something like Apache, we also use the internal system. But you can build this into any web server that you own. So as an example, we don't have this currently in mod pagespeed, but it's coming up in a subsequent release. We will be offering memcached as a backend. So when you configure your Apache, instead of storing files on disk, you can actually say, use this pool of memcache servers. And the reason for this is that when we talk to a lot of hosting providers, they're actually asking us for, we don't run our sites on a specific host. We actually run, we have a shared pool of databases, and we multiplex kind of all the requests across all the servers to provide kind of a nice load balancing. And because of that, we want to have a shared cache. So that's what memcached is there for. You can save your optimized assets in there. So, there's not a lot of surface area, to be honest. It's a big library, but as long as you can fill in these pieces, you can plug in all this logic and then enable or disable some filters. So we also provide a lot of, this is specific to, I guess, Apache, but we provide a lot of ways for you to experiment with mod pagespeed. So you can configure it in many different ways on per request level. So for example, you can pass a flag and say, turn on mod pagespeed and just do the rewrite CSS. Or you can pass in a header and ask to do the rewrite CSS. And then another example that we like to use is using Apache as a forward proxy. So I know that's not something that Varnish does, but if you're curious to experiment with mod pagespeed on your site, then you can install forward proxy and just proxy your site through it and just see what the impact is of mod pagespeed. Lots of different filters we can do. We do automatic image spriting. I talked about image resizing. We do re-encoding of images, combining CSS, combining JavaScript, minifying all of those files, etc. Extending cache lifetimes. There's dozens and dozens. And as I mentioned, some of them are in the core, some of them are optional. Optional means that It really depends on your site, right? So a great example of an optional filter is, and that does dramatic improvements to your site performance, is defer.js, which is to say, take all the JavaScript and defer it until the onload fires. That may or may not work on your site, depending on how you've architected your site. When it works, it's beautiful because it takes the loading times from like 20 seconds to 2 seconds on mobile phones. So, but that's something you need to experiment with, and it's actually very tricky stuff. So we put a lot of work into that filter. Something that's very big in the Apache community is htaccess. And all the many different ways that you can configure Apache. So you can configure it at a vhost level. You can configure it on a per directory level. So you can actually drop in kind of a custom config into your assets directory and say, just for these assets, please re-encode all of my images, or please optimize all of my images, because I know that these are the assets that are uploaded to my users, and I don't trust my users. So that's one. We heard a little bit about A/B testing. I think this is actually something we added recently, and this is very, very cool. It's kind of the next level of A/B testing. So what this actually does, it uses Google Analytics backend, and it allows you to partition the users into multiple buckets, and not just do it at a request level and say, like, I'm going to send you to this page, but the next time you come back, you may go into an entirely different page. We'll actually put you into a bucket, and you'll live in that bucket for however long you want to run this experiment. And you can enable or disable different filters, such that you can start experimenting with things like, does doing all of this performance work actually increase, or does it do anything to my site? Like, sure, the load time got faster, but did it affect my bottom line, right? And I actually worked with the Google Analytics team for a while at Google, and they're always very big on making sure that the optimizations that you do are actually making a positive contribution to your business, right? Like, we care about performance. That's why we're here. But if you want to make sure that your organization cares about performance, you need to show them that the changes that we're making are affecting, like, they're having a good business impact. That's how you make sure that you can have a sustainable effort towards performance, as opposed to just these like episodic sprints where, oh my God, our site is slow, we need to optimize it now, right? And then you kind of forget about it. So another example of kind of more advanced stuff that we had to implement in mod pagespeed is working well with CDNs or sharding. This is kind of a best practice nowadays to shard your resource across many domains. So you may be using a CDN, maybe you're just hand sharding, or you're serving your assets off a cookieless domain. Those are all good examples of where you want to use this. When you're serving that site, let's say you're serving example.com on your Apache server, and all of a sudden you're rewriting your images to be assets.example.com, we have no idea that that's the same site, right? So you can actually tell mod pagespeed and say, like, yes, I authorize you to rewrite all of these URLs. Obviously, if we rewrote URLs from, I don't know, Flickr, that wouldn't work, right? Because Flickr is not using mod pagespeed, at least at the moment, and we would break your site. That's not a good thing. This is kind of an aside, but I thought this was really cute. Forward proxy. So this was a blog post that somebody did where they took mod pagespeed and they used it as a forward proxy to their phone. So the observation being that the mobile or experience on the mobile web today is generally terrible. So if I can optimize all the sites, so instead of optimizing my site, I will optimize the rest of the web, right? Like that's the trick. So you send the request from your phone through this proxy running mod pagespeed. It fetches the actual page, gets this fat request back, mod pagespeed optimizes it and ships it back to your phone. That's the insight. So here's some examples that they used to do all of this work. It was actually, he ran the experiment on an iPhone. And the biggest one, honestly, is this part right here, which is recompress all the JPEGs or all the images as JPEGs at 75% quality, which gives you not as good visual fidelity, but on your mobile phone with a tiny screen, you can't even tell most of the time. So what did this give? So here's some examples. This is obviously not representative of the web, but here's just like spot examples. This is basically mod pagespeed in action. So you have one site where you had 34 requests, and that went down to 21 requests. So it means that we've combined multiple resources, and the total size went from 400 kilobytes to 200 kilobytes. And in this case, they were doing defer.js, which took the load time, that spinner, from 39 seconds down to 2. So that's a pretty compelling win. But this example, the next one, is kind of really drives the point home. So this is a WordPress blog, happens to be kind of a very media-heavy, photo-heavy blog. It went from 3.15 megs to 340, right? So this is a 10x difference just by re-encoding the images. And I kid you not, when you load it up side by side, you can't actually tell the difference unless you start like really zooming into the images. And at that point, you might as well just click on the image and get the high-res one anyway. So I think there's a lot of room for improvement here, and a lot like the whole premise for this work is to try to automate these performance optimizations and push this stuff to the edge. So it is an Apache module. We would love to see it being integrated into more things. We're actually kicking off an effort to see if we can integrate it, a community effort, I should say, to see if we can integrate it into Nginx. But I think it also makes sense. Well, it certainly makes sense to have, and we talked to a lot of users, to have Varnish or Squid in front of Apache or Nginx. It still makes a lot of sense to us to push more of this logic even into Varnish, higher into the layers. So, good example is Edgecast with the CDN provider, who are using this infrastructure to provide these kind of content rewriting filters at the edge. So, with that, I think I'll take some questions if you guys have any. I have a few.
I wonder, for the file combining you're doing, how do you help people avoid the issue that they have different CSS combinations on their individual pages, that you actually decrease performance, because then you have to load more, say, CSS, JS for each page?
So this is a good observation, which is to say, I may have, let's say, a base CSS included on all of my pages, right? And that always hits the cache, or should always hit the cache. And then on every other page, I just have like the little delta that ships with that page. So, and the answer there is, if you know that is the case, then just don't use that filter, right? And that's where it still makes, like, you should absolutely tune it and test it on your site. By default, we will turn on, I think, 5 or 10 filters or so, right? And this is the filters that are in a core set are based purely on kind of empirical data about general trends on the web. Most sites on the web use the same files, CSS files, over and over and over again on every single page. In your case, because you've already put in some work, that may not be relevant or as relevant. So you can disable that.
Okay, but you don't have any magic logic?
No, so we don't do any sort of like deep inspection and say like, oh, let us split files and do something like that. Yeah.
You can whitelist something.
You can whitelist specific resources. Yeah.
Do you do anything to take into account, for instance, high DPI displays like Apple Retina stuff?
So the short answer is no. I would love to find a way to do a better job of it, right? So today, so we have this general problem of high DPI images, and unfortunately, there's not a good way on the server today to figure out which image we should be serving, right? The canonical way to do that today is to do device detection. The problem with device detection, for example, the latest iOS 6, we can't actually tell the difference between iOS 6 and iOS 5 based on the UA string, right? So it's a guessing game all the time, and we can't win at that. So in general, the emerging best practice at the moment, until we have better support from, let's say, the HTML markup or whatever it is to ship JavaScript that would run the media query and then would request the assets. But that in itself is an anti-pattern, because you're deferring all the image loading until you download the JavaScript and execute it. So that's not a long-term solution. If you guys have any ideas for how we could do that better, please let us know, because I definitely think that's a big, big problem.
To take that one first, I think you should try to get involved in the HTTP 2.0 working group, because the device detection has been discussed there, and people are clearly clueless about it. And I think we need to go to a more property-based device detection. You're not really interested in what kind of Apple device it is. You're interested in what the display can do.
That's right.
So sort of the stuff that WAP did. The other thing is, I'm sort of puzzled why you think this might be a good idea on Varnish. As far as I can tell, you have a very large code footprint.
Mm-hmm.
And I would be worried that putting this into Varnish would actually reduce the efficiency of Varnish simply because of the code footprint, versus maybe having an Apache running next to it to do the job. So do you have any...
Yeah, so the general trend that we see, or the reason why we would like to see these technologies get pushed up higher in the stack is that usually you would have your cache layer, your Varnish, kind of front a whole lot of other technology, right? Because on the back end, it could be PHP, Apache, it could be a Jetty server, who knows, right? And we could build modules for each one of those, but frankly, that's just not a good use of our time. We would like to find that one choke point and say, you're the cache, you're responsible for serving the optimized assets. If we target that and all of your users flow through that choke point and we can optimize that, that would give us the highest bang for the buck in terms of the reach of the technology. I completely agree with you in respect that lots of times you will proxy back to your Apache server or Nginx. But in certain cases, you just want maybe not all of this functionality belongs in something like Varnish, but some of it might be very, very useful.
Yeah, but you're delivering it as one big lump. So I cannot say, I'll take these 3 filters. I'll have to drag in the entire code base, right?
It depends on which filters you're talking about. So for example, some filters are specifically interested in the HTML itself. Most of the wins come with respect to optimizing the actual assets themselves, right? So once again, if nothing else, like the image part could be the most interesting one, right? Like just isolate it to that. Because we know that if we just make better choices of serving images, we will significantly accelerate the web. And having that functionality available in kind of all the major platforms would actually build a better experience for a lot of users on the web today.
Always depends on HTML rewriting.
It could, but it doesn't have to, right? It depends on how far you want to go with it as well.
About the logic, you said if you were only running Apache behind Varnish, you will sort of solve the problem, won't you? But does it have to be, how much logic is it on one host? Does it have to have much contextual logic for what other files is going to get, or is it pretty one by one asset?
So let me see if I understand that. We do have a lot of clients, customers, they're not clients, I guess, users, that's the word I'm looking for, that run mod pagespeed across clusters of, let's say, Apache servers. So as long as you deploy the same config, then any request routed to any one of those servers will behave the same way. So it'll serve the same assets. And that's exactly the reason, for example, why we are developing the memcached backend, which is to say, let's say you have 100 servers, 100 Apache servers. Today, if you route your request randomly to one of those 100, it will end up optimizing the same resource 100 times because it'll cache it locally. Whereas if you have a shared memcached backend, a request to any one of those will fetch it from memcache and say, yep, somebody already optimized it, here you go.
That's already, but then if you have Varnish in front of it, that will kind of cache the finished
right.
cache.
So there's multiple layers in here. So the benefit that you get one of the benefits that you get out of mod pagespeed is that it will rewrite these resources and cache extend all of the resources to, let's say, a year lifetime, which in itself is actually a very big win because a lot of assets on the web don't change all that often based on our stats. So, but unfortunately, they don't have the right expires headers. And then, sorry, I kind of lost my train of thought there. So, yeah, I'll leave it at that. Sorry.
Okay. Just next question: how can you do change the quality of the picture, the image transparently? Does it have to change the name?
Right, okay, so that's a configuration flag that you set. You can set it on, you could create a rule that just looks for a specific file type or a file name, and then create different rules. But we will re-encode the image on the fly based on what you tell us. So for example, you can tell us re-encode PNGs as JPEGs, or re-encode PNGs as WebP, and please use this compression ratio. And then when we actually look at the image, we will run the compressor in the background. And if we get a significant enough improvement in file size, we will then serve the optimized asset. So I think by default it says something like, if we get better than 30% improvement in file size, then we will serve that image. Otherwise, not.
But if you're doing that for JPEGs and just keeping your JPEGs with the same size, can you then deliver it with the same name? Or does it have to rewrite it?
No, so I think right now in mod pagespeed we specifically rewrite it. So for example, we append the MD5 sum of the image such that if you change the underlying HTML, we can quickly fetch the new image. Okay, all right, thank you guys.